There are 8.1 billion human beings on the planet today. We build miraculous megastructures, urbanized vast areas, and have explored the majority of the globe. But can we actually be sure that we were the first society on Earth to do so?
Surprisingly, the answer might be no. Over immense timescales, synthetics and plastics decay, buildings degrade, and the Earth's crust is recycled into the mantle, removing large amounts of evidence.
Today, we discuss the Silurian Hypothesis, a thought experiment that proposes what one might look for to detect a hypothetical prior advanced industrial civilization on Earth.
This episode is for anyone interested in unconventional theories about lost cultures and civilizations, curious how we could detect a prior terrestrial society, or simply fascinated with obscure speculative theories. I'm your co-host Izzo, joined here by your other co-host Magnum.
And this is the Swerve Podcast.
Hello and welcome back everyone to another episode of the Swerve Podcast. We've got a great episode in store for you today. I hope you're ready to listen and learn.
I'm excited for this one. Listeners, I think you're really going to enjoy this episode. But if you're a first-time listener and you're wondering what you've stumbled across, we are the Swerve Podcast, and we do deep research on topics that swerve off the mainstream path, then talk about them in an uncensored way that's not boring. Here, we like to prioritize listener-requested topics, preferably topics that we know little to nothing about, doing the extensive deep dive research so that you don't have to, all in line with our overall mission to understand everything in the universe, one obscure topic at a time. So typically we cover fun conspiracy stuff, fringe or cutting edge science, forgotten or alternative history, strange myths and urban legends, consciousness, UFOs, true crime, the paranormal, or unexplained mysteries. But before we get into the basics of today's topic, Izzo, would you enlighten the listeners on our podcast tradition?
Of course, the tradition is that we like to drink while we record these episodes. So usually we'll take listener recommended drinks, maybe make a cocktail that's on theme for the episode, or just keep it basic and share with you what we're drinking. And please, we invite you to drink along with us during this episode or whenever you listen to it. So we'll start off the roundtable with myself. So for this episode, I've kept it basic and I'm drinking a rye and Coke. So that's...
Nice.
Yeah, that's what I got.
So rye and Coke. Fuck yeah.
Yeah.
No, it's good. Rye and Coke. I think you're on a big streak for rye and Coke.
Probably. Yeah.
No, that's great. I have an interesting drink. I made something quite random. I made a Sprite margarita.
Oh, okay.
Have you ever heard of that?
No, I haven't. No.
My thought process was, well, first of all, I have the ingredients to make a margarita. And I was like, well, maybe I can get like Sprite. It's kind of like synthetic.
Yeah.
Like Diet Sprite. It's kind of fits into the Silurian Hypothesis a little bit. Not really, but it's what I could do. So I got a Sprite margarita for this episode. We will have the drink recipes posted on our social medias if you're interested in what the drinks look like or the recipes. So with that, how about we hop into the basics?
Let's do it.
So this topic won the June 2024 voting block. So I just want to remind listeners, if you would like to help direct the topics that we research on this podcast, you can do so by signing up as a free member on our Patreon. You can do that at patreon.com/theswervepodcast.com. All you got to do is press the blue join for free button, and then you create an account with an email address. We release a poll every month on the 1st, and you have till the 15th to vote. So it's like a 2-week period. It's composed of 5 or so random topics from our master topic banks, our master list of topics, and all members can vote. So it's just a great way if you want to help direct what we research on the podcast. For this topic, I had a misconception for what it was. I thought we were going to be talking about a lot of lizard people shit. Personally, I don't know about you, Izzo. Did you have that impression?
No, I mean, I had the same impression just because it is based off of, pre-human advanced cultures. So you think about it and lizard people, aliens, whatever it could be.
Yeah. So, but I was pleasantly surprised to find out that this is all based off a scientific white paper that came out of authors from NASA and the University of Rochester. So this is basically a science-based episode, which is awesome. And we're just going to be adding a bunch of swerves to it as we go. But I like it. I'm satisfied. I'm happy to go into this one, specifically this scientific white paper that the Silurian Hypothesis is based on. This was published in 2019. So this is very recent. It was published in the International Journal of Astrobiology. Surprising. So this actually has some grounding to it. These authors, they titled it the Silurian Hypothesis. Would it be possible to detect an industrial civilization in the geological record? This is written by Gavin A. Schmidt out of the NASA Goddard Institute for Space Studies and Adam Frank from the Department of Physics and Astronomy at the University of Rochester. Does that surprise you a little bit?
Definitely, that it has scientific weight.
I thought we were going to be talking about lizard people this whole time, because I should say, this topic, when it won the voting block, it won by a huge margin. There wasn't even any close contenders with this one. Everyone voted for this one. And I was like, here we go. More reptiles. Because like everyone likes reptiles. I don't know. All of our reptile topics are like some of our most popular episodes. And I'm like, I don't understand it. I don't get it. But no, this is only reptile adjacent, not 100% reptile. The Silurian Hypothesis asks a fundamental question, and that is, did an advanced technological civilization exist on Earth at some point in our pre-human history? And then the question is, if that could be the case or might be the case, how would you even know? What would you need to do to detect that even? You might be wondering what the Silurian Hypothesis, like why are we calling it this weird word? It's actually named after a 1970s episode of the TV series Doctor Who, in which a buried race of intelligent reptiles called the Silurians were awakened from hibernation by a nuclear reactor. This is where all the lizard stuff comes from. This is why I thought this was a lizard topic.
I mean, for the authors of the scientific paper to piggyback off of this TV show, I don't know, it would make you associate it with lizard people automatically. So why they would do that, I'm not sure.
Yeah, well, the thing is, I never looked into this topic before, but I had seen titles of it. And when you look at the thumbnails, there's always like lizard people in the titles. And I was like, what? Yeah. So I just had the assumption, but I never looked into it until we did this topic. But the reason they have, lizard people in the thumbnails and stuff, it's like, well, because it's based off this Doctor Who thing where there actually was an ancient race of lizard people before humans. While we're still in the basics, I think we can all agree as a society, maybe not everybody, but there's a general interest in searching for intelligent life. There's this general vibe that, we don't really want to be alone. We're interested in what's out there in space. The search for intelligent life, this is also an important aspect of astrobiology, not just general interest that human people have in society. So there's actual scientists that look for radio communication signals, and they've been doing this for decades. There's some organizations we've brought up on the podcast before, such as the SETI Institute, which is the Search for Extraterrestrial Intelligence Institute. And this is a nonprofit research group that literally their whole mandate is to look for signals of some other form of life. Radio communication signals, these presume, if you're trying to detect these, you presume technological advancement on the other side. That's the reason that these signals are being sent. And if you assume technological advancement, then you're going to assume that there must be an intelligent species that developed that signal, and that would likely involve industrialization. So like you're assuming when you're looking for these signals that there is some intelligence associated with it. But the question is now, this whole topic we're talking about today, instead of looking extraterrestrially for signals, what if we invert that and we start looking terrestrially for signals? Instead of looking into outer space, what could we find on Earth? This reminds me of the crab people from South Park, the mole people of Gears of War. Like, what can we find? Is there things terrestrially in the Earth? The whole point of the paper is to outline kind of what evidence would there be of a terrestrial industrial civilization that may have existed millions of years in the past. What would we look for if there was such a thing? 4 reference points, quick while we're in the basics. Complex life has existed on Earth for 400 million years. but we have only been industrial for roughly 300 years. It's an incredibly small fraction of time that we can confirm there's been industrial civilization on Earth versus how long there has been complex life on Earth. It begs the question then, maybe it is reasonable to speculate that there was an advanced society in the past, given the immense time scale. This is the idea here. Not saying there is, but if you just wanted to speculate, it's crazy, but it's not incredibly crazy. It's not impossible. It's just infeasible, maybe. I don't know. Or unlikely, rather.
No, that's a pretty crazy stat to put out there. 400 million years of complex life and only 300 has been industrial.
That we know. Yeah, exactly.
That's wild. It's the old adage of never giving up, maybe. After 400 million years, you'll make it.
So finally. You're saying there's a chance.
Yeah.
Yeah. So the problem is detection. We alluded to this in the intro. If you're trying to detect an extremely ancient society, there's a ton of issues with this that I was not aware of until looking into this topic. First, we know life is extremely rare. We only know of one instance of it, and that's on Earth. So already we know life is rare just based on that statistic. We can't confirm any other planets or solar systems that we're aware of have life. I want to bring up this point now because I'm going to say some crazy shit in the next section that shook me to my core. Again, as often these topics do. I'm going to prime it now. So this might not make a lot of sense, but just bear with it because we're going to bring it up again later. We know life is rare, and we would need evidence for another life form having emerged on Earth prior to the current tree of life, that pre-life as we know it life form being wiped out, and then the current evolutionary tree of life as we know it emerging again to give the Silurian hypothesis much more credence. That's a big mouthful, but to say it in another way, what if we could look back in the past and identify a form of life, and that form of life, let's say 350 million years ago, we identify it, and then we identify that it was wiped out by some event, and then we identify the current tree of life that we have now. Wouldn't that give this hypothesis a lot more credence because it would be like life emerged twice on Earth instead of just once?
Yeah, that makes sense.
So this is one thing the Silurian hypothesis wants to look for is, can we identify any evidence of life and it being wiped out and then all of a sudden life comes back? Because then maybe life isn't as rare as we thought. So I want to prime that right now. Little confusing, but it'll make more sense when we break into some of the more detailed sections shortly after the basics. The other thing that's crazy, this is a huge problem for detecting an advanced civilization. Every 500 million years, so every half billion years, Earth's crust is recycled into Earth's mantle. I wasn't even aware of that.
Neither was I.
It's not even possible to detect evidence of an extremely ancient society. So say it's like a 700 million year old society. It's like, well, it's back in the Earth's mantle, likely. Most of the fossil record is deleted because of this phenomenon. There are some regions on Earth that this process hasn't occurred or occurs much slower. So I forget the exact locations. There's somewhere in Australia where there's an entire region that hasn't been recycled. So it's like a very hotly studied area because, well, the fact that it hasn't been recycled, it's like really great to find fossils there and shit. But this is a huge problem, right? Like if the society was too old, you would likely just delete it. You wouldn't even know. It would just get recycled into the mantle. So the question is, well, what do we look for then? If life is rare, it happened once, and if we want to look back and see if it happened multiple times, but we can't because it just gets recycled away. Well, what are we doing? Can we even know? What do we look for? So this will bring us into the next section. Here, I want to diverge and digress a little bit from the Silurian hypothesis and talk about the Drake equation. I think we've brought this up on the podcast a couple times, but I would like to look at it, explain it right now, because it makes it really cool looking at the Silurian hypothesis if you can understand the Drake equation. So let's talk about this. Have you heard of the Drake equation before, Izzo?
I think so, in one of our previous topics, but haven't really looked into it much more than that.
This is considered the second most famous equation of all time. You know, losing out to E equals MC squared, obviously. But second place isn't that bad, right? Not Gretzky, but Lemieux, maybe. Canadian reference. But this is named after Frank Drake, an American astrophysicist and astrobiologist. This is a common mathematical framework used to speculate on the number of advanced extraterrestrial societies within the Milky Way galaxy. So this is basically what we're going to talk about here. This is a fun math equation. If you wanted to estimate if there were extraterrestrial societies, how would you go about estimating how many there were? Like how would you do that? So this is also a thought experiment, but it is a cool equation. And if you could fill out all the variables, you actually could estimate this. But as we'll learn, some of the variables we know, some of the variables we don't know. So the Drake equation reads as follows, and I know listeners can't see the equation, so this is going to sound like a bunch of like gobbledygook. But what it is, it's N equals R times FP times NE times FL times FI times FC times L. And we're going to talk about what all this is. N, this is what we want to know. This is the number of civilizations in the Milky Way galaxy whose electromagnetic emissions are detectable. So if we knew all those variables on the other side of the equal sign, so if we knew R, if we knew FP, NE, FL, FI, FC, and L, we would actually be able to estimate the number of civilizations in the Milky Way galaxy. And that would be pretty cool. So R, this is the rate of formation of stars suitable for the development of intelligent life. So if I just put this very simply, all R is just how many stars. So if you look in the Milky Way, it's like how many stars are there? So what's cool, we actually know that value. We can figure out this value based on astronomical observations. This is a known value. So R we actually do know. FP, this is the fraction of those stars with planetary systems. So put simply, how many stars have planets orbiting them? How many planetary systems are there? And this is actually, we do know this term as well. We can estimate this based on astronomical observations. And what's interesting is most stars have planets. Kind of cool. So most stars, they have like a solar system, just like our sun. So that's not incredibly rare. NE, this is the number of planets per planetary system with an environment suitable for life. And right, that kind of sounds like we wouldn't have that value or be able to estimate that value. But you can actually estimate this value. You can look and use proxies such as the Goldilocks zone, or another term that's used is habitable zones. And it turns out there are many planets that are in these habitable zones, like the same distance from their star as Earth would be from the sun. You could consider that, a Goldilocks zone kind of thing. So what I'm saying is, in the Drake equation, already 3 terms, we kind of have estimates for them. We know R, we know FP, and we know NE. That's kind of cool. How many stars? How many of those stars have planets? And how many of those stars with planets might have a suitable environment? We kind of actually know that. The other terms, though, we don't know. So we can't estimate. So FL, this is the fraction of suitable planets on which life actually appears. To put that simply, how often does life appear on planets with suitable environments? Planets with the habitable zone. How often would life appear? Right now, this is impossible to know. Only Earth, we know that this happened. So we can't really assign a value to it. But this is where things get crazy for me, and how this can tie into the Silurian hypothesis. There's a study in 2015 by Bell et al., and it's called Potentially Biogenic Carbon Preserved in a 4.1 billion year old Zircon. That's the title of the paper. You can look it up. We'll have it in the description in our reference section. This is really fucking cool because the study indicates that life may have emerged 300 million years earlier than we previously thought. So before this paper, the scientific consensus, and honestly, this still would be the scientific consensus because one paper doesn't topple everything, but it's 3.8 billion years ago. This is when life emerged on Earth. This paper is saying, well, we have new evidence and we think it's 4.1 billion years ago. So 300 million years earlier. That's very interesting. So to give listeners context, the Earth formed 4.54 billion years ago, essentially on like a geological time frame. Basically, life occurred almost instantly, right? So Earth forms 4.5 billion years ago. And then according to this study, 4.1 billion years ago, we have the first evidence of life on Earth. That's fascinating already. That seems very fast. You have the planet form, and then within, 400 million years, there's evidence of life. That's pretty interesting already. But this isn't the crazy part yet. What's interesting about this is the time frame. There was a massive bombardment of the inner solar system around this time. Actually, this bombardment, when you look at the moon, the largest craters, they're believed to have formed from this bombardment. So the question is, was this life 4.1 billion years ago wiped out because it had to endure this massive solar bombardment? And it seems like probably, yeah, it probably was. So what does that mean? Did life begin again 3.8 billion years ago? 300 million years after the bombardment or whatever? Did it restart? What's crazy is, did life fucking happen twice on Earth? That's what this paper's saying. This is why it's so crazy. And what that means is life might be way more common than we think. And we could actually use this to estimate the damn value of FL in the Drake equation. That is insane to me. When I came across this, I was, I don't know, like having a crippling panic attack. Because the main thing that everyone always says, this is the number one, and it's a good take. I like it. It's a fine take. The take is, well, we only have evidence of life occurring once, so there's nothing out there. Don't get your hopes up. Don't be amazed. This is the best it gets. Just be happy, the miracle of life. But if it happened twice on Earth, that's out the window. This is common. Life is common. If this is real, I'm not going to say that this is 100% confirmed or anything like that. There's just slight evidence. There's this one paper, 2015. But I think it's wicked. Life might not be as rare as we thought. And this ties into the Silurian hypothesis, because if life's not as rare as we thought, well, what the fuck do we know? Right? Like, we don't know. Doesn't it give it a little bit more credence, like I was saying in the base? Like,
it does, yeah. If it took roughly 400 million years for life to begin on Earth, and it takes another 400 million after a wipeout, like, that's substantial evidence.
It's crazy. I mean, it's a long time.
Yeah. But
it's not that long in comparison of how old the Earth is, or even in the comparison of the universe, for that matter. What, universe is like 14 billion or something, and then Earth is 4.5 billion years old, and then it's like life on this Earth, it's like takes 300, 400 million years.
Yeah, and it was quicker the second time around. Maybe not everything was completely wiped out, like the pre-markers for life.
See, I don't know. This is a question I don't know. I don't know enough about it. We're already pretty in speculative territory. I just think it's very interesting.
No, it is.
I think it's very interesting. So I wanted to emphasize that, and I want to finish off with the other terms are in the Drake equation, just to put a bow on this section. The other unknowable terms in this equation are Fi. This is the fraction of life-bearing planets on which intelligent life emerges. So remember, the one we were just freaking out about, or I was freaking out about, is the FL one. That's if you have a suitable planet, how often does life actually emerge? That's what that term is. This one is, if life does emerge, how often does it become intelligent? We have one estimate for this. It's like human. Like, I guess you could argue dolphins. You could argue like octopi. Those are intelligent, right? You could even maybe argue AI in like the next 10 years. Like maybe that's a new form of life or something. I guess the term would be, if life does emerge on a planet, like intelligence emerges like 4 times based on what we have on Earth. You know what I mean?
Yeah.
But like you could consider a dog like a border collie intelligent too. So it's like, where do you draw the line kind of thing? I don't know. So you know what I'm saying? It's kind of a muddy term. It's not extremely clear.
Yeah.
The next term, FC, this is the fraction of civilizations that develop technology that produce detectable signs of life. Again, to put it more simple, how often does intelligent life actually produce detectable signals? So if you have life emerge on the planet, some of that life becomes intelligent. What fraction of that intelligent life actually builds technology that you can detect? And in that case, it would be 1. It would be humans, with the caveat that AI might be doing that in like the next 10 years. So who knows? The last one is L. This is the average length of time such civilizations produce these signs. And to put it simply, how often are the signals sent? That's it. And we can't really know this term because, again, we're the only life we know of that is sending signals. So L, FC, and FI, it's like basically just humans. That's it for now. Overall, with the Drake equation, the first 3 terms are knowable, or at least they're able to be estimated using astronomical observations. But the last 3 to 4 terms, they're basically not knowable. And we just set them to like 1 or whatever because it's just humans. But what's interesting is that FL thing to me is, I don't know. The fact that there's evidence that maybe life emerged twice on Earth, that's very, very compelling to me. And I wanted to emphasize that. So can we actually look back in time on Earth and uncover signatures of a prior intelligent industrial civilization? We'll look at this in the next section. Before we continue the episode, if you enjoy listening to our crazy shit, the people you hang out with probably will too. Do us a solid and please pass on this episode to your social media friends on Facebook, Instagram, X, or other platforms. We would definitely appreciate your support. I'd also like to take this time to shout out some of our valued listeners. Shout out to Pinhead Larry, Brianna N. Preston, Snap-on Took My Kidney, Soupboy96, On the Internet Nobody Knows You're a Cat, Leah Hing Reynolds, Toby P2711, Schlootopia Wyako45, and Fish Out of the Water for liking our social media posts. And lastly, huge shoutouts to our newest initiates on Patreon. Shout out to Lemons100, The Amazing Rando, Mr. Bunny, and Denise Okutchin for joining our Ride the Wave tier. Massive shout out to Sean Campbell coming in at that Slap That Ass tier. And finally, epic, massive, hyper awesome shout out to Shelly Terry for joining our producer tier. To everyone else, thanks for listening, and feel free to submit your topic or drink recommendations at theswervepodcast.com. May good karma and vibes with you all. Back to the show.
Human technological and industrial activity will likely leave behind what we call an anthropogenic signature in the geological record. Would similar signatures in the geological record be detectable from an advanced species that existed in Earth's distant past? How would one go about detecting a so-called Silurian signature in the geological record?
So what's interesting, we do know that other intelligent life existed on Earth already in the past. In the last section, we were arguing like whether dolphins or octopi were intelligent, but that's like present day. We have those. But in the past, there was also intelligent life. It wasn't just humans. And we do know that this existed. So this is kind of sooner than the Silurian hypothesis, but there is physical evidence for other non-human cultures that existed in the last 2.5 million years, such as the Denisovans, the Neanderthals, and there was other bipedal hominids. For example, as indicated by the Laetoli footprints, which is pretty interesting. It's a footprint trail that's almost 27 meters long, and it includes impressions of about 70 early human footprints. They're called Australopithecus afarensis. So my point is, we do know in the past that there was intelligent civilization. It just wasn't industrialized. These we're intelligent creatures. The problem is this really isn't far back enough in time to be applicable to the Silurian hypothesis, and it doesn't really fit the criteria of like an advanced civilization, which would be much more interesting. So the question is, how are we going to do this? I outlined some of the problems with detecting a distant past advanced civilization in the basics, but just to go through a couple of them again, it's just too far back in the geological record. If you go too far back, it's too hard to examine. So basically anything further than 2.5 million years ago, I guess things are just sparse. You can only find evidence of these things in deep drilling and mining operations or in ocean sediments due to recycling of the ocean crust. So I think it's just a general challenge. Even if you were a scientist trying to do this, how often are people digging extremely deep? It would be mining operations and like deep drilling. You'd have to like collaborate with them as a scientist to like figure this out. It's just not easy to do. The other thing, fossilization is rare. This is interesting. We only have a few thousand near complete specimens, and this equates to only a handful of individual creatures across thousands of taxa per every 100,000 years. You have like a handful of things every 100,000 years, and like that's the best we can do. That's like nothing. Imagine right now if we had like 5 things. Like 5 million years from now, people are looking for fossils of our time present recording this podcast, and they find like a giraffe, a zebra, and like what's some other dumb shit, like a manatee, and that's it. It's just such a small representation of what there actually was, but it's just that's what happened to fossilize.
Yeah, it's a weird thing to think about. Even having fossils, like trying to determine what the creature actually looked like is very speculative and inaccurate most of the time. Just imagining what they would find with this era's fossils.
Well, I mean, look at the whole dinosaur thing. Like I grew up thinking dinosaurs were like these lizard skinned things, and it turns out they're actually like feathered.
Yeah.
Like what? What? I hope that's right, or that's what I heard.
I heard the same thing. So.
I don't know. The other thing, the coverage of the planet is very low. So even in our highly urbanized present day human society, we only cover less than 1% of the surface of the planet. So again, that means in the far future, a post-human society digging for technological evidence of the advanced human society of our present day, this would be akin to finding a needle in a haystack. Even despite our present abundance, it would still be difficult. So for all these reasons, and again, in the basics, I talked about the recycling aspect every 500 million years. It's actually not easy to look for things in the very distant past. But how can you get around this? What are some things you could look for? Is it possible? It turns out there actually are some possible things you could look for that were outlined in this paper written by this guy associated with NASA and the University of Rochester. The first thing is stable isotope anomalies. So you can look for anomalies in the carbon-13 to carbon-12 ratio. This ratio is increasing in the atmosphere, oceans, and soils due to the burning of coal, oil, and natural gases. How this works is that carbon-13 is biological in origin. It is in carbon sources like oil and coal, which formed from organic material deposits such as plants, animals, and waste products. So if you're seeing spikes in carbon-13 in the geological record that you're looking at, compared to the greater pool of inorganic carbon, this could be used as evidence for an industrial society. So like our society right now, we have a carbon-13 to carbon-12 ratio. There's more carbon-13. That's because we burn fossil fuels. So the question is, if you went back in the geological record and you saw evidence of a ratio where there's more carbon-13, it's like, well, were they burning fossil fuels here? Is this an industrial civilization? That's what is meant here. And that's something you could look for. You could also look for anomalies in the delta oxygen 18 value. This is a measure of the ratio of stable isotopes of oxygen 18 or oxygen 16. And this is commonly used as a proxy for temperature change in the geological record. Given that human global industrialization has also produced increases in non-CO2 greenhouse gases like N2O, CH4, and CFCs, the authors of this paper, they predicted temperature increases will be detectable in surface ocean carbonates. So by looking at this delta oxygen 18 in foraminifera shells, maybe that's the word of the podcast, foraminifera, you can estimate the temperature of the environment that the shell was formed in. That's pretty crazy.
Yeah.
You can also look at cave records. There's the stalactites, those icicle-shaped deposits. Apparently, you can look at them to see the measurement of this ratio of stable isotopes. You can also look at lake ostracods, and ostracods are found commonly as fossils and are still living today in all aquatic habitats, and they have shells, and you can look at the delta oxygen 18 ratio in the shells. More shell stuff. Pretty interesting. So you can like estimate temperature based on like fossilized shells. You could also look at high latitude ice cores. So basically what the authors were saying here, you could look for spikes in temperature. And the way you look for spikes in temperature is looking at the delta oxygen 18 ratio. And you can look at the delta oxygen 18 ratio by looking at shells of foraminifera. You can also look at the stalactites in caves. You can look at the lake ostracods, and you can look at ice cores. So those are some things we could do today to look for temperature spikes, right? Because if you have an industrialized society, you would expect that they're also emitting, like CO2, the N2O, methane, and the CFCs. So you would expect there to be a temperature spike. That's what I'm trying to say here. There's another isotope anomaly you could look for. This is delta nitrogen 15. This is a measurement of the ratio of the two stable isotopes of nitrogen, nitrogen 15 and nitrogen 14. Nitrogen 14 is preferentially uptaken as a lighter isotope. It's not as heavy as nitrogen 15. So as a result, samples enriched for nitrogen 15 can often be introduced through a non-biological context. So for instance, in our present society, the Haber-Bosch process, we use this to produce nitrogenous fertilizers. So the authors, they predicted that looking at anomalies of delta nitrogen 15 ratio could be evidence for industrial societies in the past, right? Because today we're an industrial society and, we've increased that ratio, and it's because of our fertilizer production. So maybe past industrial societies did a similar thing. The second category, this has nothing to do with isotopes at all. This is looking at the sedimentological records, which is a great word as well. Sedimentological. So you can look for greater deposits of sediment in coastal environments. There's many different things that can contribute to this. So one, deforestation and agriculture. This increases soil erosion, so it would result in more sediment. And you would expect an industrial society to be doing those things. Canalization of rivers also results in increased oceanic sediment deposits. And you would expect an industrial society to be doing this with rivers. Increased temperatures produce greater precipitation, which leads to more erosion regionally and ultimately results in more sediment being deposited, right? So again, if we're burning the industrial societies using energy sources like fossil fuels, you'd expect there to be more temperature spike. You could look at the stable isotopes, but then you also might expect there to be more erosion because there would be increased precipitation due to that temperature increase. The other thing, you could look at rising sea levels contributing to greater coastal erosion, resulting in more sediment deposits. Again, that would all tie in again to like the idea of like warming the earth idea. In a nutshell, you're looking for more sediment.
And there's, I guess, natural ways of getting more sediment, but then there's also man-made acceleration of sedimentation deposits.
Yeah. You'd be looking for a spike in the geological record is the idea. Yeah. You could also look at the composition of the coastal sediment. So for instance, maybe there's more of it, or maybe there's not more of it, but you could look at what it's composed of and make some conclusions with this. So the authors say to look for increased levels of calcium carbonate because acidifying oceans would have more of this molecule. You could also look for altered ratios of strontium 87 to strontium 86, as well as osmium 187 to osmium 188. This would be due to increased continental weathering, and I guess that ratio would be important. You could look at that in the sediment. You could also look at anthropogenic fluxes of lead, chromium, rhenium, platinum, and gold and see if they're higher than their natural sources. And you would likely see a spike in fluxes of these metals in river outflows and higher concentrations in coastal sediments. The last one, we don't know for sure yet on how long of a time frame plastics will be around, but you could look for plastics. And one of the problems is that plastics are typically buoyant. So if they were in the ocean, they would eventually be broken down by ultraviolet radiation from the sun because they're floating and they get broken down. But if they were deposited in the coastal sediment, they might resist degradation. So you could look for signs of plastic as well in the composition of the sediment. A third major category is extinction events and faunal expansion. So noticeable disappearances in the fossil record will likely be detectable, likely due to anthropogenic technology and industrial activity. We kind of already can get this, right? A lot of shit dies just because we expand into habitats and stuff. So you would expect a prior advanced industrial society to be associated with extinction events as well. So you could also look for decreases in the fossil record or whatever at the time that you're looking for. Another thing that I find very interesting is looking at the rapid expansion of certain species in the fossil record. So for instance, right now, because we displace certain areas, there's certain invasive species that just flourish. So mice, rats, things like this, they're all over the world. They're not just in their native region. So if you were looking at a prior advanced civilization, you might expect the same thing to happen. There'd be extinction events, but there would also be this rapid expansion in certain organisms that really wouldn't make sense. I find that actually, that's a pretty interesting, I found that pretty clever. I like that. The fourth thing you could look at is non-naturally occurring synthetics. You could look for the presence of persistent organic pollutants in ocean sediments. So there are certain organic molecules that are resistant to degradation, such as halogenated organics, CFCs, and CF4. So the paper mentions that some of these break down over thousands of years so that they would be undetectable, but some of them might actually remain in ocean sediments. So if you found spikes in those molecules, perhaps that could be some evidence of a prior industrial civilization. One important one, I think this makes a lot of sense, is looking for synthetic biomarkers such as steroids, leaf waxes, alkanons, and lipids. These could be preserved in sediment for many millions of years because they're synthetic in origin, meaning they're not biological or they don't resemble biological versions. Like lipids are biological as well, but like if there's synthetic versions, that would be very interesting. That would be a very strong clue, I would imagine, if you could find that. The other thing, this is another interesting one. Synthetic molecules, they have a different form. They call it chirality. And basically, the way you can think of chirality is just like look at your hands. You can't superimpose them on each other, your left hand and your right hand. Although they both have 4 fingers and a thumb and a palm, they are different in a 3-dimensional space aspect. You can't impose them on each other. So molecules can have that same property. And there are certain molecules that there's certain natural molecules that have a certain chirality, and that's the only chirality that's found in nature. So for instance, amino acids, they have an L form, and with sugars, the natural form is a D form. So if you found a different chiral form, that would be very suspicious, and that would indicate that this is probably synthetic and that this is not natural. And that would be some evidence perhaps of industrial society as well, or industrial activity. I like that one a lot as well. This next example is fairly obvious, but I think this would be a huge smoking gun if this could be detected. The fifth one is look for specific extremely stable radioactive isotopes. One quick thing, are you tired of eating bland flavors day in and day out?
Yes, it's absolutely unbearable.
Do you want every meal to have extra bite?
Of course, I want this hell to end.
Then you should try Flavors of the Forest Bigfoot Breath, a premium raw garlic dust. I've been dusting Bigfoot Breath garlic dust, especially the spicy variety, on many things, such as eggs, steaks, pizza, but really whatever.
Thank goodness for Bigfoot garlic dust. I thought I was a goner.
If this sounds interesting to you, you can check them out using the link in our description or go to flavorsforest.com/swerve.
Now, we do receive a small kickback from purchases through our link at no cost to you, so it is a great way to support the show if you choose to do so.
That's flavorsforest.com/swerve. Use promo code SWERVE for 15% off your order of Bigfoot Breath garlic dust. flavorsforest.com/swerve, promo code SWERVE for 15% off. So interestingly, not all radioactive isotopes that we use in the normal process for using nuclear energy last a very long time. A lot of them can be completely broken down, so they would be irrelevant for detecting a past industrial society, but there are certain versions that have extremely long half-lives. So for example, plutonium-244 and curium-247, they have half-lives of 80.8 million years and 15 million years respectively. So it's possible that if there was sufficient quantities of these radioactive isotopes deposited, perhaps maybe from like a nuclear exchange or something, there would be detectable sources of this. The only natural source of plutonium-244 would be from like a supernova. So like, this is why I think this would be a huge smoking gun if you could find this, because it would have to be from some kind of advanced technological process for it to be on Earth in high enough concentrations. I have a sixth one. This wasn't in the paper, but I found this in an Isaac Arthur video and I really liked it, so I just thought I would bring it up. This is just some common sense shit. One is, if you look in the geological record, if you find a lot of right-angled structures that just happen to fossilize, that actually might be very important. That might be a huge cue or a signal. We know we can find tree fossils that are 300 million years old. So you would assume if you have like a lumber-based structure, such as a house, it could also be fossilized. Right angles, they're not really natural. You don't usually find right angles in nature. So if you found a lot of these right angles fossilized, that could be an indication of a prior industrial civilization. I thought that was a neat idea. The other idea was finding big-brained organisms in the fossil record. I mean, this would obviously be rare and suffer from the limitation that this would be rare, that this is rare, but this could be a signal to add credence to the Silurian hypothesis. The other problem, though, would be, how do you know this is kind of saying like there's an intelligent past species. What if it didn't have bones? Like, what if it was an octopus-like creature? You know, it just wouldn't fossilize. So there are some more limitations with that as well. But I thought that was also a cool idea. So to summarize, in this section, we have outlined a possible future signature in the geological record based on present-day human activity. This signature would be assumedly detectable in the geological record by our future post-human entities on Earth, and we could call this the Anthropocene signature. Does that make sense? Like, everything we just said is basically, we're using humans right now, what we're doing, what signature we're making in present day, and we're like, could we find that signature in the past? So we could call that an Anthropocene signature. So that's kind of what we're looking for. So what we did is we defined what that signature is. We have the isotopes, we have the sediment, we have the extinctions, we have the expansion of certain invasive species, etc. But by outlining this Anthropocene signature, we infer that a past industrial civilization on Earth may have created a similar detectable signature in the geological record. So we should be able to go to look for this signature if it does exist, and we could test the Silurian hypothesis. So the question is, are there time periods that overlap with this Silurian signature? I'm going to call it the Silurian signature instead of an Anthropocene signature. I like that better. Could we find that? We'll talk about that in the next section.
We have a signature to look for now. Are there time periods in the geological record that overlap with the Silurian signature we outlined in the previous section? The answer is a surprising yes. And the signature shows up more than once.
So the white paper outlines several events that display portions of the signatures we discussed before, including stable isotope anomalies, increasing temperatures, extinction events, and changes in the amount and composition of sediment in the sedimentological records. So where can we find events that match this Silurian signature? And what's crazy, there's actually a bunch that match this, which is, I find, hilarious and maybe somewhat disturbing. But we'll talk about the limitations of this later. But for now, there's a bunch that actually do match this. The Paleocene-Eocene thermal maximum event, this happened about 56 million years in the past. There are detectable abrupt spikes in carbon and oxygen isotopes near this Paleocene-Eocene transition. There's also rapid increases in temperature during this time period, as indicated by altered isotope ratios. Remember, we were talking about the change in the delta oxygen 18 and oxygen 16. You can look at that, and they do see that. There's increases in kaolinite in many sediments, indicating periods of time for greater erosion. There's higher sedimentation rates, and there's many metal abundances that are spiking during this event. So again, it kind of matches some of those categories that we talked about earlier. There's Eocene events that happened 54 million years ago. There was multiple hypothermal events that are noted in this period and carbon isotope anomalies. There's also high sedimentation rates, and these have been termed the Eocene layers of mysterious origins. So no one knows, even in the geological record, this is a very strange time period. Some other stuff, there's the Cretaceous and Jurassic ocean anoxic events. Ocean anoxic events are identified by periods of greatly increased organic carbon deposits and laminated black shale deposits. These are times when significant portions of the ocean, either regionally or globally, become depleted in dissolved oxygen. There were 3 major ocean anoxic events in the Cretaceous. The first was the Wishart event 132 million years ago. And then the cleverly named event, this is the second event, called the Ocean Anoxic Event -1A around 120 million years ago. And then the also cleverly named third event, the Ocean Anoxic Event -2, which happened 93 million years ago. Those are some of the worst names of all time. Like, I don't know. If you're going to name something, you have name it something, name your discovery. Don't name it 1A and 2.
I mean, that's what the first guy did.
The first guy did he said the Wishart event. He named it his name.
Yeah.
It's better. I don't know. This is a lost opportunity. There was also at least one similar event that occurred during the Jurassic. This is 183 million years ago. And what's interesting, these ocean anoxic events, they kind of overlap with a lot of the Silurian signature that I talked about in the last section. This includes increased global temperatures, so you get more CO2, more methane. There's increased seawater values of strontium-87 and strontium-86, as well as osmium-187 and osmium-188. The ratios, so you have those altered ratios. This would suggest increased runoff. You also see altered nitrogen isotope ratios. So for instance, you're seeing more of the nitrogen-15, which, remember, we were talking about that ratio being important because it would suggest, maybe like industrial fertilization or something. You do see that. You see increased metal concentrations. There's a ton of them, like nickel, thallium, chromium, cobalt, cadmium. So you see that. And then the last thing, you see shifts in sulfur isotopes. So it's very suspicious. What's going on? Is this natural? I mean, probably, but maybe not. There's also the early Mesozoic and late Paleozoic events. So some notable events just quickly here. The late Devonian extinction around 380 to 360 million years ago was one of the big 5 mass extinctions. It is associated with black shales, and black shales these contain a lot of organic matter, so they're enriched in metals, and ocean anoxia. There was another notable event in the late Carboniferous around 305 million years ago in the Pangean tropical rainforest collapse. There's also the end Permian extinction event 252 million years ago. So in summary, if you actually go looking for the Silurian signature, you're going to find some shit. There's several events that could be argued to display markers of the Silurian signature. And I'm not saying that this is perfect evidence or even great evidence, but I just find this a very interesting perspective, and it puts kind of a new lens on looking at the past that you wouldn't really think of otherwise. And I do want to mention, while I'm summarizing this section, if you read the paper, the authors actually do note, they're like, our analysis is pretty weak. This is more of a thought experiment. So they actually do deliberately mention that.
Yeah.
But it's still very cool. And it's interesting that you could look for things, and identifying things you could look might alter your mindset. And maybe you would start looking for different things that you wouldn't normally look for. Like normally people aren't looking for radioactive isotopes at all. You know what I mean? Like that's not, because it's like, why would you have equipment to look for that? But maybe now you'd be like, well, maybe we should do that. But what we're going to do in the next section, we're going to talk about some of the limitations of the Silurian signature and maybe poke some holes in what we're even able to detect.
How reliable are the markers in the Silurian signature we have outlined? Can we really trust this analysis? Is it even possible to detect a past industrial society on Earth?
So one of the main problems is that known abrupt natural events overlap with an Anthropocene/Silurian signature. So essentially what I'm saying is everything we outlined in the past section has really good natural explanations. So these natural explanations usually involve contemporaneous episodes of tectonic or volcanic activity. So that's where you get a lot of like, the metals, the altered isotopes, the increase in temperature, stuff like this.
Yeah.
For instance, one thing is the anoxic events, like the poorly named stuff that I was going on about. A lot of these are linked to extreme episodes of volcanic outgassing. So volcanism contributes to the buildup of CO2 in the atmosphere and increased global temperatures. The intrusion of basaltic magmas into organic-rich shales and or petroleum-bearing evaporites may have released large quantities of CO2 or CH2 to the atmosphere. So this is kind of interesting because you might go look at these Silurian signatures and be like, hey, there's kind of like, right now we see more of the carbon-13 versus carbon-12 ratio because we're burning fossil fuels, right? And that shouldn't be the case. But when you go look in the record, you see that, and it's like, well, were they burning fossil fuels? Like, what the fuck? Like, was this an advanced industrial civilization? Like, it looks like there's a signature for fossil fuels. And it's like, well, actually, they were coming from this process. So that's like a natural explanation. It's not actually like a civilization that was using energy of this huge natural process. These abrupt events of warming, the carbon influx, increased runoff, and erosion all appear similar regardless of the geological period. Nothing sticks out extremely hardcore. So you can look back and you do see fluxes, but it's not as crazy as you would expect an industrial society to be. And it's similar. So it also suggests natural causes. Big smoking gun, why I don't think these past events, even though you could argue they have some aspects of a Silurian signature, there's no radiation stuff found. But I also don't know if it's even being looked for. So that's another big thing. But you're not finding the plutonium-244, stuff like this. You're also not finding synthetics. So no altered, chirality that you wouldn't expect. No like synthetic versions of molecules that you wouldn't expect in a biological organism. So, and no plastics either. And I think those would probably be the biggest smoking gun if you could find stuff like that, but there hasn't been. So that also takes away value from it being, or credence away from this being an industrial thing and more a natural thing. So overall, it kind of seems just in general, the data is just insufficient to provide evidence for a prior industrial civilization at this time with the markers we know. You can explain them naturally, and that's fair. This is just kind of more philosophical to an extent. Specific markers for industrial activity are speculative. Humans use plastics. We use synthetics as well, certain synthetics. but a prior industrial civilization may have gone down a completely different path of technology. This is an assumption we're making. If we're using those as markers to look for, that's actually speculative. We don't know for sure that will provide evidence of the Silurian hypothesis. So finding nothing, like I had just mentioned in the past thing, I'm like, well, we're not finding these things, so we lose credence. It's like, well, you might not actually be losing credence because like we don't know if necessarily the same technological path was taken. And I think that's fair. It's kind of like a little retort to what I just said. The delta carbon-13 signal, this also seems like a great candidate for monitoring the use of carbon-based fossil fuel, but also it's possible that in prior industrial civilization was green. Maybe they were using solar, hydro, and geothermal. So therefore, they wouldn't have the same geological footprint that you would expect. So again, just because that signature is not there doesn't necessarily mean, I don't know, kind of have all your ducks in order for this type of search. I thought that was a nice point.
Yeah, essentially we right now are not the perfect version of civilization. So why would we be looking for replication of our own activities?
Totally. So that's an interesting point. The last point I want to note is if the onset of industrialization is extremely rapid and it leads to the advanced civilization killing themselves, we've kind of flirted with that as a society many times. Like, how close have we come to nuclear catastrophe? And now we're creating the AI overlords, which might be great, but it also might not be. You know, is it possible to even detect a civilization in the record in the time frame from start to finish? If they destroy themselves in like 400 years, is that even going to show up in the record? 400 years is nothing.
Yeah.
It might be impossible to even detect if that's the case. And to end this section, I really liked the authors. They have a great quote at the end of their paper. And I figured before we roll into final thoughts, let's end with this banger quote.
While we strongly doubt that any previous industrial civilization existed before our own, asking the question in a formal way that articulates explicitly what evidence for such a civilization might look like raises its own useful questions related both to astrobiology and to Anthropocene studies. Thus, we hope that this paper will serve as a motivation to improve the constraints on the hypothesis so that in the future we may be better placed to answer our title question.
End quote. Let's hop into final thoughts. Before we move on, we would like to give massive props and credits to our producer tier on Patreon. Thank you to David Cheesem, Shelly Terry, Alexius Ryan, Big Ball Small Wiener, Batcat Meatloaf, Velcro Shoe Guy, Tosh Collins, Honest Elliott, Nikki Hansen, Justin Ware, Danny Brown, and Christian J for enabling today's episode and the continued growth of the show. What's the most important thing to you after going through this process?
I guess the most important thing would be the number of ways to actually detect some sort of civilization activity within sediment and just isotopes like that. But the other thing that I found like super intriguing was that the mantle recycles itself. Like, I had no idea.
Yeah.
So here I am thinking we could just like dig and uncover as much information as we want. Nope, you only get like 500 million years of data. So that was like a big learning moment, I guess.
I mean, I think that's pretty crazy, that the recycling thing. But actually, funny enough, so that one paper I brought up in 2015 that might suggest there was life twice, or it could be argued that there was life twice. So the region where they found their sample, I mean, that region hasn't recycled for 4.1 billion years. So there's like specific pockets where you can actually find stuff. And I find that amazing. Like that is crazy.
Yeah.
One of the things that I found it very interesting that it was extremely hard to disprove or prove the hypothesis. You would think it would be very easy to detect an advanced industrial civilization, but it's actually it's not impossible, but it's infeasible. Like, what are you looking for? How are you going to detect this? That's what I find crazy. It's like, you can't
Yeah.
Someone could say, "Oh, there was an advanced civilization," and it's like you can't say there wasn't. Like what are you gonna say?
Yeah.
You could just say, "I'm pretty sure there's not." That's what you can say.
It is interesting that like we can't even answer that question terrestrially, let alone extraterrestrially. So we just like don't know anything.
We don't know anything. It's shocking to me. That's what I find extremely shocking. The biggest swerve for me on this whole thing, well, it was that when I realized that life might be not as rare as we thought, because the fact if it happened twice on Earth, that is a big deal. That is a huge, big deal. If it happened twice on Earth, I don't even know what that means, because that means life is common and almost certainly in the billions of, I think there's 10 billion Goldilocks planets in the Milky Way. I think that's a number I came across. Almost certainly there's life, right? Almost certainly.
Yeah.
If it is true that it happened twice here. And I would find it's the argument can't just, what's the argument then? So say it is twice. A skeptic would be, you can no longer just say, well, it only happened once, so like we're special. What are you gonna? Oh, it only happened twice, so we're special. Like, what are you gonna? It's just you're just gonna keep doubling down. Yeah. It's a tower of turtles. It's not great. Then we find a third one. It's like, oh, actually, there was 3 on Earth. Oh, it happened 3. It's like, at what point does your hypothesis just crumble?
Yeah.
And to me, I've always leaned to that hypothesis not being correct. I don't think we're the only life forms in the universe for sure. And in our galaxy, probably not either. And if this is true, this 2015 paper, it'd be really great to do a whole topic and dive into that deeper. But that was very shocking to me, because I was like, holy shit, these guys might be onto something crazy. And that is frightening. It's extremely frightening. If life is common after a planet forms, it takes like 300 million years, you have like life, and it's in the right region. That is crazy. And it not only does it happen, it like happened again.
And I mean, even if we take those unknown constants or variables and like set them to 1, the three variables of that equation that we do know, you still get over 10 billion possibilities of life.
I think you get 1. Yeah, I think it just turns out it would just be 1, unfortunately.
Oh.
Yeah. Yeah,
Wow.
that's the problem.
That sucks.
Yeah. But maybe it could be 2 now. But actually, yeah, so I don't know. It would actually be more than that.
Never mind.
I see what you're saying, though. I mean, the Drake equation's kind of, it's just for thought experiment. It's those variables right now, there's no way we can measure them, but it's just very interesting. Yeah. I have a lot of hope for the future. I have a lot of hope for the future now after studying this topic. And if there is mole people, that's also whack. Like Gears of War got it right. Like, fuck. All of our scientists, all our geologists, all of our, prestigious universities got it wrong, and Gears of War 3 figured it out. And actually South Park. That's funny. The other thing I find, this is probably the most, this was just funny to me, like in a blackly comical way. Almost everything about you is almost for sure 100% completely going to be erased. Almost 100% like for sure. And I just find that hilarious. You're gonna, in 500 million years time span, it's going to get cycled back into the mantle. So like whatever you're like, I'm fighting for legacy, man. I want legacy. Well, your statue and your book written about you, it's just cycled back into the earth. That's funny. Unless you go to Mars or you're in the cloud somehow and it's like satellites maintaining your legacy, I guess. I mean, if you have a legacy, I guess put it in a fucking satellite, because otherwise it's going to get recycled into the mantle.
That also means that like your search history might not get deleted if it's in the cloud.
Everything about you is completely wiped away except your search history. That's hilarious. That's the only remaining fact about you as a human and any of your achievements. It's your search history in the Google satellite cloud. That's fucking even worse. That's hilarious. That is such like a That is so classic. That's exactly that's so perfect for society. That's such a great metaphor. Everything about you will be completely wiped away except your search history.
Yeah.
Oh, that's good. That's a great time to end the podcast, I think.
All right, so before we roll out of the episode, be sure to go right now and sign up as a free member on Patreon so that you can vote on what topic we record at one of our next recording sessions. Signing up takes 1 minute and it's completely free to do. So just go to patreon.com/theswervepodcast, press the blue join for free button, create an account by entering your email and password, and boom, you have instant access to voting, which Magnum will explain more about.
So we're releasing a poll of 5 to 10 topics from our master bank of recommendations on the 1st of each month. And then voting is going to be open until the 15th of each month. So if you hurry up and sign up, you can cast your vote before voting closes or before you miss out on the next round of what we're going to be dropping. We also have 3 other paid tiers on Patreon if you would like to support the podcast. We have a $1 Ride the Wave tier where we drop 1 extra Patreon exclusive episode each month. It's an episode like you've heard here. You will also get a shout out on the podcast. We have a $3 Slap That Ass tier where you'll get early access on Sundays instead of our typical drop time of Wednesdays to all of our main topic episodes. But you will also get a Patreon exclusive holographic sticker pack mailed to you. And then finally, we have our $10 producer tier where you will be credited at the end of all main episodes that we do, as well as receive 1 monthly special bonus Patreon exclusive episode. Right now, we're doing our Connect the Dots series, where Izzo and I input all the topics we've ever done, Patreon exclusive and main, into a random number generator and have it output the topics. And then at random, we try connect the dots of 12 topics that are output in any way we possibly can. And they're absolutely hilarious. So I will mention those. Make sure you sign up for topic voting so you can help kind of direct what topics we're going to research and record next. And I would like to thank everybody for listening. Okay, now that that's out of the way, we wanted to try something different today and roll out of the episode with a listener's song. We're going to play a dope track called The Reprieve from an indie band called Hypermusia off their EP Equivalent Exchange. We'll have a link to their Bandcamp page in the description if you liked what you hear. But lastly, I wanted to try something new here. If you're a listener of the show and you produce music that fits the themes we cover or our vibe in general, please reach out to us. You can find our contact or contact us through theswervepodcast.com. We have a form you can fill out there if you wanted to reach out to us. I'd just like to try something new here and feature underappreciated art if we can and help people with exposure in some small way. So please, if you are a listener of the show and you produce music that's dope and you think it would be great on the show, please feel free to reach out. And with that, slap that ass
and ride the wave.
Because the main thing that everyone always says, this is the number one, and it's a good take. I like it. It's a fine take. The take is, well, we only have evidence of life occurring once. And so there's nothing out there. Don't get your hopes up. Don't be amazed. This is the best it gets. Just be happy, the miracle of life. But if it happened twice on Earth, that's out the window.